All right, hello once again. This is Jeff Scott of Rankin Technical College. And right now I'm going to be going over Chapter 2 of our Microsoft Visual C Sharp 2015 An Introduction to Object-Oriented Programming by Joyce Farrell. Under the guise of Evan Gudmested, I have changed the beginning of these. We're going to have a general objective for each chapter. This chapter is to explain C Sharp variables. And then the author's objectives, okay, the more specific objectives will be shown. And this will be shown both at the beginning of the chapter and at the end of the chapter. So we're going to learn how to declare variables. We'll learn how to display variable values. We'll talk about different types of variables, such as integral, which is typically int or integer, which is whole number. Floating point, which are variables that can have a decimal place. Arithmetic operators, addition, subtraction, multiplication, division, maybe a few more. The Boolean data type, which is true, false. Numeric type conversion. So when you mix different types, if you add an int and a double, for example, what happens? All right. A character data type, which represents a single character. The string data type, which can represent multiple characters. We'll talk about how to define constants and also a little bit on enumeration. And accept console input. Now you started to look at that in the last chapter where I showed you that read line, but we'll go into it in more depth and breadth of coverage in this chapter. So, when you declare variables, and the author's got some definitions here, I defined a variable in the last chapter as a named memory location whose value can vary. And that's pretty much, in fact, almost exactly what you see on the slide right here. All right, when you declare variables, you can make a variable a constant. If you make the variable a constant, then as long or after the program is compiled, you cannot change the value of that variable. A literal constant, well, if I make a variable called age and I set age, let's say equal to 21, then 21 is the literal constant. What you'll also see is C# is what's known as a strongly typed language, which means that not only when you declare a variable, not only do you declare the variable, but you have to give it what's called a data type. And as mentioned on the slide right here, you're giving it a data type so that the system knows the amount of memory to put aside for that piece of data and the type of value that it can hold. All right. Now, they talk here about intrinsic data types. You can see them here. They're also in your book. This same slide is shown in the book. It takes up almost all of page 49. But they're the built-in data types. All right, we will look at those. You will use those throughout the semester. Now, one of the things that's supported also here is what's called the Unicode. And Unicode is not a data type. It's a character set. It's a way that you represent characters internally in a computer. Now, back in the olden days, like in the 1980s, 90s, whenever, there really wasn't Unicode. But at that time, almost everything that happened with computers was national. So it was within the United States of America. So we used what was called, or what is still called, the ASCII character set. ASCII. And it stands for American Standard Code for Information Interchange. And it had 256 possible characters. And it represented every character pretty much that's available in the United States, the English character set. The problem is today we're no longer national, we're international. So if you want to have an application that will accept Chinese, let's say, all right, the ASCII is not going to cut it for you. The Unicode character set represents, I believe the last time I heard, well over 100,000 different characters as opposed to 255 for ASCII. Now, if you look at this slide, you might say it's busy. It's really not a bad slide. The thing to realize is when you look at everything from byte through U long, so these 1, 2, 3, 4, 5, 6, 7, 8 different types that you see, these first 8, those are all types that hold just whole numbers, typically called ints or integers. You'll notice that different types have different ranges. For instance, a byte can be between 0 and 255. A signed byte between -128 and 127. I'm not going to read all these to you. You can see them. All right. Back in the olden days, when you had an int, ints were all 16-bit ints. So that was basically, that was the size that you had, -32,768 to +32,767. But now you've got 32-bit ints that go from -2 billion to +2 billion. You've got 64-bit ints that is 9 times 10 to the 18th. I have no idea what number that is, but it's a pretty big number. And a guy I used to work with, he'd call those BHNs. And I'd say, what's a BHN? He'd say, it's a big honking number. And that's pretty much what it is. The next 3 that are shown here, these are types that can hold a decimal place. You've got float and you've got double. The difference between these is, if you look, is that floating point is approximately, what, 3.4 times 10 to the 38th. Whereas double is 10 to the 308th. So you get more precision with a double than you do with a float. Decimal is typically used when you're working with monetary values. And then you've got the other things that are in here. You've got a char that can hold a single Unicode character, Boolean, all right, which holds true or false, a string, which holds some kind of string, 0 or more characters, and an object, which we won't get to until about chapter 9. So if you look at the example that's shown on the slide here, and it's a good example, it says int my age equal 25, and I wish. All right, so a few things about this. The type is integer, which means that whatever comes to the right of the equal sign can only be a whole number. Okay? The name of the variable is my age. Now, if we had just said int my age, semicolon, that would have been legal. Because the part before the equal sign is what's known as the variable declaration. The part that's the equal sign and after is known as the variable initialization. So this says the equal sign means assignment. This says assign 25 to the variable my age. All right? It's pretty much what I just went over with you. Another example here. Notice double. Some money equals 39.45. Probably representing $39.45 since it's money. So you might say, well, why did they make it a decimal? I didn't write the book. I have no idea. All right, notice here they've added the dollar sign to it. There's other ways you can do this. We'll talk about formatting, etc., and we'll get into some of it now, and you'll see it throughout the book, that when you put what's called a format specifier on when you format, then basically what happens is it'll add the dollar sign for you, and it'll add any commas. So if you've got $123,356, it'll put $123, comma 356, something like that. So again, we'll get this format string in just a minute. When you work with these things, you'll also work with placeholders. Now, this is one place where C# in many ways is different than Java, and it's similar, not identical, but more similar to a language like C, which is one of its predecessors. This is a placeholder right there. All right, so it says the money is, boom. The $0 means you're going to have one argument that comes after the comma, and that's some money. All right. And you might say, well, what's the big deal? It looked just like this one does. And it does in this case. So why do you want to use it? You don't have to use it. But a lot of times when you are printing out multiple variables on the same line, it makes more sense to use these placeholders. And there's examples. I don't know why they did this, but the author did. Now what appears after that placeholder can be either a variable, like we have right here, or it can even be a literal value. That's okay. There's absolutely nothing wrong with doing that. All right. Now when you come in here, you can have different field sizes. So notice, you might say, well, why would you want to do this? Well, notice what we're saying is the width of each one of these is 5. All right, so it's space, 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 space 4, space, space, space 56, space, space 789 type of an idea. So you use this to right justify. You can put a negative number in there to left justify. So there's a lot of different ways that this can be used. Okay. All right, so let's talk about some of these data types in a bit more depth and breadth of coverage than we had previously. So if you are following along in the book, I'm on the bottom of page 56. All right. Again, the integral data type can store whole numbers only. You see the different possibilities. All right, and you might look at that and go, wait a minute, Jeff, the char is there. That wasn't there before. Char is kind of a animal into and of itself, and we'll get into that in just a bit. All right. Again, floating point numbers can contain a decimal place. So notice this. Floats can hold up to 7 significant digits of accuracy. Doubles 15 or 16, so they're about, really more than twice as precise to use a double. And decimal can hold 29 digits, but a smaller range. So again, typically you use those for financial calculations. Now, notice what they say in there. If you want to make something a float, you can put either an upper or a lowercase f after it. If you want it to be a double, it's the default, but if you want, you can put a D after it. And for decimal, you use M. You might say, well, why M? Well, they couldn't use D because it was already used with double. All right, you can also work with scientific notation. Now, when you format these floating point values, all right, and I'm on around page 60 in the book, it says C# displays floating point numbers in the most concise way it can while maintaining the correct value. Now, that may or may not mean a whole lot to you, but I just want to mention something to you, that computers in many ways, in many programming languages, computers are imprecise animals. And what I mean is, if I do this, if I say int, no, I can't say int. So if I say double sum equals 0.1 plus 0.1 plus 0.1, you get the idea here, plus 0.1 plus 0.1, I'm just going to leave it right there. All right. Now you might think that since I'm adding 0.1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times, you might think, well, when you get done, you might think that the answer is going to be 1.0. And technically, you're probably wrong. Probably it's going to hold something more along the lines of 0.999994613 or something like that. Because computers are very imprecise animals. All right. Now they show you examples that you can use to specify different things in here and the X's and the O's, this is going to make much more sense. Whoops, darn it. This is going to make much more sense, I believe at least, when we actually start to go into this stuff in a little bit more depth and breadth of coverage. All right? So you can see these. If you say that something is a C, and you can use an upper or lowercase c, it means formatted as currency. You say D double F fixed or floating point, or fixed point, I guess. And there's other ones that you can use also. Okay? But again, you might say, well, you didn't really tell us very much in there. Yeah, because the way you're going to learn most of this stuff, especially things like that, the way that you're going to learn this is by actually interacting with it in a program. All right, binary operators. First of all, there's actually one that's missing here, just so you know. And don't ask me why, but the author didn't put it in. All right, so you can see binary operators, but there's also something in here that's called a unary operator. So let's say I've got the number 56, just came to mind. All right, so I want to come in here and say int age equal 56. All right, and that's totally legit. There's absolutely nothing wrong with it. But if I wanted to, I can also do this. I can put the unary plus sign in front of it to just say for sure that it represents a positive 56. Now, can I put a negative there? Typically, yes. It wouldn't make much sense, and so I might check that if I was going to be inputting into a program to make sure that the age was a minimal age that was positive. All right? But so age isn't really a good, let's just say, some variable. The point is, if it can have a negative number or a positive number, and with either one of those are called unary operators. We're used to binary operators, so we're used to something that looks like this. X equal y plus z, x equals y minus z, x equals y times z, x equals y divided by z, and finally x equals y, what's called modulo z. So let's suppose right here, I'm going to get rid of this that I just did. I'm going to say here int x, not x, we'll say x equals 0 to start, equals 0. Int y equals, I don't know, 17. I'm just doing this right off the top of my head. Int z equals 3. All right? Just to make sure that everybody's with me here. So 17 plus 3 is 20. 17 minus 3 is 14. 17 times 3 is 51. 17 divided by 3. Now, this is a little bit different because remember, these are integers. So the actual answer would be 5.66666, etc. But since it's an integer, it throws away the decimal component, and it's going to give me an answer of 5. And finally, this modulo, which you may or may not be familiar with, is also called a remainder operator. So it says divide 17 by 3, and what's the remainder? Well, 3 goes into 17 5 times, and the remainder is 2. So those are your major arithmetic operators. All right? Now, they talk here about this rule of precedence. I'm going to cut this down a little bit here, move this up, or try to. And what I want to mention to you is the rules that apply here are the same rules that you used and learned back in high school algebra. In other words, you do you do multiplication and division, and modulo for that matter, before you do addition and subtraction. So in other words, if I've got here z equals y plus x divided by 7. I know that's kind of a silly thing, but you do the division first. So it'll take the value of y, which is 17. It'll divide it by 7. I'm sorry, the value of x, which is, well, we said it was 0. All right. And then we'll add that to y. Okay. So the point is, and maybe I should have made this one z, and I should have made that one x, and I should have made that one y or something like that. But the point is, if I want to do this addition before I do the division, I have to put this into parentheses. And if you want to, you can even really kind of go nuts here and do that. Okay? When you got this, these are known as nested parentheses. They're parentheses within parentheses. You do the innermost set first and you work your way out. All right? So here's your major operators. I showed you examples of those already. Now there are shortcuts. Let's talk about all of these different shortcut examples that are in here. All right? So we'll go back to what we just had up here. And let's have x, we'll set x equal to 0, and we'll have y equal to 17. And we'll just get rid of z for now. Okay, we don't really need that one. If I want to add 1 to y, there's 4 ways I can do it. I can say y equals y plus 1, which will work just fine. I can say y, whoops, line these up so you can kind of compare and contrast them. I can say y plus equals 1. I can say y plus plus, or I can say plus plus y. Every one of those will take the value of y, which is 17, and add 1 to it, making it 18. All right? This plus equal, I can put any number after the plus equal. You know, if I want to put 57 in there, I can do that. This will only add 1. This will only add 1. This, of course, too, I could come in here if I wanted to and put 57 if I wanted to do something like that. All right? So there's plus equals, there's minus equals, there's minus equal, there is times equals, there is divided by equals, and finally, there is modulo equals. These are all set up. So this line that you see right here, y modulo equal 57 is the same as saying y equals y modulo 57. All right? Just so you're aware of that. All right, the ones that are a little bit different are these right here. So I'm going to get rid of this. If they're on a line by themselves, to say y plus plus and plus plus y, if they're on a line by themselves, like we have them right here, there is absolutely no difference between them. Where there gets to be a difference is if I say x equals y plus plus, as opposed to saying x equals plus plus y. Again, this is called the post increment operator because you add to it after. This is called the pre-increment operator. What's the difference? It's called post if the plus plus appears on the end. It's called pre if the plus plus appears at the beginning. So what this does right here, in fact, let's put some room in here. This is the same thing as saying x equal y, and then y equals y plus 1. So in other words, when I'm done, x equals 17, y equals 18 when I get done. If I did it this way, this is the same thing as saying y equals y plus 1, x equal y. So what's the difference? Now, x is equal to 18 and y is equal to 18. So what's different is the value that you are adding the value to. So here, since this is the post increment, you assign and then you increment. Since this is the pre-increment, you increment and then you assign. Now, not only is there a plus plus, but there's a minus minus. So we could have changed all these here from pluses. In fact, let's do it. Change every plus in here to a minus. All right. So this is, again, the post decrement operator. So this is going to assign 17. All right. And when we get done, it's going to say y equal y minus 1. So y will be 16. Here, it decrements first. So x and y are both going to be 16. Now, if you find that confusing, all right, using stuff like this, then either don't use it or just put it on put it in 2 lines as opposed to 1 line. My philosophy, and hopefully Evan agrees with this, but my philosophy is when you are learning this stuff, you should be striving for understandability. All right, so there's the unary operator. And I already mentioned the decrement. Boolean operators. Booleans can hold true or false values. Literally, that's it. Okay? And I'm jumping over here because I'm back in the book. I'm on page 68. So for Boolean, in some languages, you literally use the word Boolean. In this language, you use the word bool. Is that a big thing? Not at all. But for example, I can do something like this. I can say bool married equal true. Since that variable is of type Boolean, I can say bool married equal true, or I can say bool married equal false. Those are the only 2 values that married can hold. Those are the kind of variables you make Boolean variables. There is no gray area to the computer. It is or it isn't. All right, comparison operator compares 2 items. Well, when you compare 2 items, you can compare them for equality, inequality, to see if one is greater than the other, to see if one is greater than or equal to the other, to see if one is less than the other, or to see if one is less than or equal to the other. All right. And again, if you are following along, this is the chart that is shown in your book on the top of page 69. All right, so let's just put a couple values in here. We'll say int x equals 7, int y equal 4. All right? So x equal y. Well, you should know already just by looking at that, that's going to be false. All right. X less than or equal to y. Well, is 7 less than or equal, or I'm sorry, 7, this is not equal. This is equality, 2 equal signs. This is inequality. Exclamation point equals, sometimes called bat equals or bang equals. Is 7 not equal to 4? Well, that's true. All right. X greater than y. Well, is 7 greater than 4? Yep. So that's true. Greater than or equal to. Well, 7 is greater than or equal to 4. So, so true. And finally, x less than y. Is 7 less than 4? No. Is 7 either less than or equal to 4? Again, no. So if you can understand what I have right there, it really doesn't get any harder than that. All right? So, here's the book's examples. I don't know if this chart is in the book. Yeah, I guess, like I said, it's the one that's on page 69. and they've got some stuff in here. This is all stuff that we're going to look at as we go on. Let's just take a look at what's going on in here. All right, int value equal 4. Bool is 6 more equals 6 greater than value. Is 6 greater than 4? It is, so that's going to say true. So it says when value is 4, is 6 more is true. That's what you get right there. That first placeholder 0 is for that. The second placeholder 1 is for that. All right. Then we set value equal to 35. Is 6 greater than 35? No. So when the value is 35, is 6 more is false. You have to start thinking in the way a computer thinks. And you might say, well, that's going to be a stretch, or that's not going to be a stretch. Most computers actually have the intellect of about an 18-month-old child. All right? They don't understand much more than typically than an 18-month-old child. All right, starting on page 71 and going on to the next couple pages, the author talks about type conversions in here. Now, the key thing to realize is what, if possible, what the system always tries to do is it tries to compare apples with apples. So, if you perform different kinds of arithmetic operations, addition, multiplication, subtraction, all right, etc., then, and if you've got different types, what happens is C# chooses what's called a unifying type. And it does it based on its own hierarchy. All right, it's called an implicit conversion or an implicit cast. All right. So for example, all right, a double equal an int. Well, if I'm working with both an integer, so let's say that's 7, and a double, let's say that's 5.3, and I want to add them, what the system does behind the scenes is it takes that 7 and it basically promotes it, makes it 7.0, so it can add the 5.3 to it. Now that's not a great explanation. Please take a look at what's in your book. I can also force this to happen. When I do this, and int equals int a double. All right? So let's say again, that was 7.3 and that was 5. So this is going to say, give me the integer portion of 7.3, which will be 7, and assign that to an int. This is called casting. Notice it appears on the right-hand side of the equal sign. What that means is it never actually changes the value. It's changing a copy because it's on the right-hand side. All right, you can take a look at the example on the bottom of the page. And jumping up to page 73, we talk about the character type. Notice with the character type, you use single quotes. That's not a number. That's the string 9. Think about addresses. All right? Addresses are not used in calculations. So if my address happens to be 123 Main Street, and I just want to grab that 123, all right? Well, that'll be a string, but in this case, let's just say 4, all right? Or 9 like we've got right here. This has an arithmetic value of 0 because it's within single quotes, so it is the character 9. All right, escape sequences. Here's the main ones that are shown here, and the same chart is shown in the book on page 74. Let's just cut to the quick here. The ones you're going to use almost exclusively will be \n for a new line, \t, it's like you hit the tab key, and occasionally at least \\. You might have reason to use any of these, but those are the ones that you're going to use the most often. Now, you may or may not remember, but a long time ago, near the beginning of this chapter, we talked about the fact that a char data type in C# can hold any single character, but it can hold also any single Unicode character. So if we look at this example that's down at the bottom of the screen here, We've got char letter equals single quote A, single quote. All right, that'll assign the capital A to letter. The bottom one does the same thing. Char letter equals single quote backslash U, and backslash U, it's an escape sequence, and it's not shown here, but what it means is what follows is a Unicode value. So use the Unicode value 0041, and if you look at the Unicode character set, 0041 is a capital A. So these two statements are exactly identical to one another, and either can be used. All right. Whereas when you work with a character, it can only hold a single value. You can also work with a string, and a string will be in double quotes, okay? And you can compare strings. You can use the equals and the not equals. There's also an equals method, a compare method, and a compare to method. These are all explained in the book on the bottom of page 77 and the top of page 78. When you compare two strings, they're compared lexically. So, for instance, if I do this, if I were to come in here and say, I'm just going to grab these examples I had and remove them. Oops. And I'll say string name1 equals Mark. String name2 equals Mary. What happens is the system goes through what's called a graphical, I think that's correct, comparison. And it says they're equal, they're equal, they're equal, they're not equal. So it's comparing it a letter at a time. If for some reason, let's say that I don't ask me why, but I said Marky. All right, it wants to compare apples with apples. So what it will do with this example, since there's 1, 2, 3, 4 characters, 5 characters here and 4 here, it'll add a space to make sure they're the same size. All right. So as it says here on the bottom of slide 30, a string is considered equal to, greater than, or less than another string lexically, and that's what I tried to just show you. All right. And there are examples in here too. So notice Amy compared to Amy is true. Amy compared to Matthew is false, which should make sense. There's more examples here, and these are taken right from the book, pages 78 and 79 in the book. All right. Now, one thing that's mentioned, I don't know if it's in the slides here or not, so I'm going to mention it. And this is near the top of page 79. The first full paragraph, it's a little paper clip here. It says, in C, a string is immutable. What that means is that if I'm writing a program and I've got this, let's just say we'll make this string, we'll say name. All right, so we set it equal to Marky right here. So I'm going to put here ... which means that somewhere in here we've got more code. I don't know what the code is. I don't care what the code is. But so we'll put a comment here that says more code. Okay? Then later on in the program, I come back and I say name equals, I'll put my name in there. Okay? What happens when we do this is the system comes out into the memory of the computer, and imagine the memory is just like loads and loads, just millions of, if not billions of mailboxes, and they all have a number associated with them. So let's say that when I do this first one here, and I say string name equal Marky, all right, that the system goes over to location in memory, location 10,000, and it puts Marky in there. Now, it doesn't put in M-A-R-K-Y. It puts in a collection of zeros and ones that represent M-A-R-K-Y. But later on, if I change the name from Marky to Jeffrey, it's going to grab a different area in memory, maybe location 3, 4, 5, 6, 7. So what it does is that value is still in location 10,000, but it's not being used anymore. All right. Now this holds the correct value. And what happens is the system will eventually do what's called garbage collect what's at that memory location. We'll talk about that in another class. All right. Strings have a lot of different methods that you can use with them. And a real popular one is a substring method. A substring is a string within a string. All right. So as you can see here, we've got water. And if we say start at 0, because when we're computer people, we start at 0. So that's the 0th location, the 1st, the 2nd, the 3rd, and the 4th. So if I say start at 0 and go one location, it says give me the W. Start at 0 and give me two locations, it's WA. Start at 1 and give me two locations, it's A and T. Start at 2 and give me three locations, it's TER, etc. And again, if I were to come in here, and I showed you this in the last chapter, because I'm just trying to kind of tie things together here. If I, again, go out to msdn.microsoft.com, and I type in here, I click the key here so I can bring up the search bar. I'm going to type here C# string methods. String functions, it doesn't really matter. All right, string methods. Let's change it to C to string functions. It's probably going to be in there as that. Oh, maybe not. But there are some examples. Okay? So there's a lot of different things, in other words, that you can do with this stuff. All right. On the bottom of page 80 and going on to page 81, the author talks about constants. A named constant is it is a variable, but it's a variable whose value once set cannot change. You do it with a keyword const. And typically when you do a constant, it's an uppercase. So I could come in here and let's just say I wanted to do this. I could say const legal age, and it's different in different states, but let's say 21. So after the program compiles, after I do this, if I try to put legal age on the left-hand side of an equal sign again, I'll get an error message because that's illegal. I can't change the value once it's been set of a named constant. Named constants can help your program become more self-documenting. It's much easier to look at legal age and know what you're talking about. Enumerations, the middle part of page 81, going on to 82 and 83. And enumeration, basically, you're defining your own data type. So I've got a new type of variable here called day of week. And its values are Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. So by default, the system looks at these as being integers. And it says Sunday is 0, Monday is 1, Tuesday is 2, Wednesday is 3, Thursday is 4, Friday is 5, and Saturday is 6. If I wanted it to be 1, 2, 3, 4, 5, 6, 7, all I have to do is just come up to this one and say Sunday equal 1. And there's the example. Notice on the bottom of the slide here, it says programmers say using enums makes the values type safe. So only the appropriate type of variable can be used. Now, some people really like to use enumerations, and they use them almost whenever they can. Other people could care less. In many ways, I guess it's kind of what you're comfortable with. All right. On the bottom of page 83 and going on to page 84, we looked a little bit in the last chapter at write line. The opposite is read line. Read line allows you to get input. So as it says, read line accepts all characters entered by the user until they press enter. You can, if you want, to assign that to a string. All right. And as it says, if you want to assign it to a different type of data, so if I was asking for an age, and I put in 21, that's not the number 21, it's the string 21. So I'd have to convert it to the proper type. So here's an example. Notice what it says here. Enter the price of an item. And then it says item price as string equal read line. So that's the 2877, but it's not $28.77. It's literally the string 28.77. So here we convert it over to a double. Then we multiply it by our tax rate, which is 6%. So it says that's the cost of our item and that's the cost of our tax. Notice there's a lot of these two methods here. This is the top half of page 86 in your book. And all of them are going to, and they're all going to a different type of number. Even char, which gets you the Unicode number associated with the character. All right. Finally, we've got the parse method here on the bottom of page 86, on page 87, and page 88. As an alternative to using these different conversion methods, you can use a parse method. This is very similar, not identical, but very similar to the kind of parse method that you use in a language like JavaScript. Parse, as it says, means to break something into parts. So parsing a string turns it into its numeric equivalent. All right. There's another program that's in here on the bottom of page 87, and it goes up to page 88. So we've completed the chapter, and what have we done? We learned how to declare a variable. You also learned, if we take a second to go back here, that when we did this, and I mentioned this to you before, I'm going to get rid of all this stuff. So I'll put string right here, okay? All right. If I put just this, that right there, what you see, that is called a variable declaration. I'm declaring a variable. This, if I come back and I say name equals Jeffrey, that is called a variable initialization. Now, like most programming languages, C# could care less if you did it in 2 lines or if you did it in 1 line. Either one works. Okay? All right. We talked about displaying variable values. We looked a little bit on how to display things. We also looked at, with the integers and the floats, we looked at the different types of integer variables. We looked at the different type of float variables, and we looked at their different ranges. We looked at the major arithmetic operators, addition, subtraction, and the ones that come before them, unless parentheses are used, those being multiplication, division, and modulo, which is the remainder operator. We talked about the Boolean data type, which only allows true and false. We talked about numeric type conversion, all right, when you are going from one type, when you are combining 2 different data types. We learned about the char data type, which can hold either it holds just a single character, but I can set it up to hold that character's value or its Unicode value. And it's always in single quotes. We learned about the string data type, which is always in double quotes. If I come in, let's say that I don't know what the person's name is, all right? Or maybe we had somebody who was just born, all right? And they say, what's the name? We don't know yet. We haven't figured it out. If I do this, all right, that is actually called the empty string. It's void of a value. There is no value in it, but it's legal to do that. You usually don't see this char. There is no empty char value, so I don't think this will even work. I can't say like initial equals single quote. I don't think you can do that. But I can say char initial equals single quote space single quote. that is permissible. All right. We talked about using const to declare a constant. We talked a little bit about enumerations, and you'll see some of this stuff later on as we go on in the book. Finally, we looked at as an alternative to the write line that we used in the last chapter, using read line. And that's it for the chapter. All right. So, what we will do, and I wish I had kept that open, or did I? In the next chapter, Chapter 3, we're going to go GUI. And what I mean by that is we're going to come in and actually start building and talking about some of the other controls that are on here. I'll build a few different applications for you as we go through that. And I'll be back with that shortly.